In this video, I'm going to talk about an interesting problem and its solution. The problem is this: you are going to host a huge party, and that huge party would have 1,000 bottles of wine. However, you know that exactly one bottle is poisoned. How? Now, luckily, you have 10 rats, and the way you would find out which bottle is poisoned is by feeding wine from some of the bottles to some of the rats. Here we are assuming that the rats can take a lot of wine. The party starts in 1 hour, which is exactly the time it takes for the poison to kill any rat that drank it. Now, how will you find out which bottle is poisoned without the part before it or just at the beginning of the party? So first, let us see a solution which isn't the best but is a head start. So we label each bottle, which I'll represent with a circle here, with a number from 1 to 1,000. We label the first bottle with the number 1. We represent the 53rd bottle with the number 53. We represent the 200th bottle as 200, and so on. After we have labeled all the 1,000 bottles, we're going to feed one rat drops 100 to 1,000, and then we'll feed the second rat wines from 101 to 200, and basically we'll continue. Thus, and then after we have given the wine to the rats, we'll wait an hour, which is the time that the wine takes to kill the rats. Now, we'll see which rat is dead. For example, if the 7th rat is dead, then you know that the poison bottle has number between 601 to 700. That way, you can save 900 bottles of wine while losing 100. Now, we're going to see the solution to save all the 999 bottles of wine. So, this solution needs binary numbers. For those who don't know what are binary numbers, I will give a brief overview. So, you probably know our good old 10 decimal place. It is where we have 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we have power. And the number is represented by the numbers in its places, just like place value. For example, 685 has a 5 in the ones place, a 8 in the tens place, and a 6 in the hundreds place. And the places go from the first ones place to the tens, hundreds, thousands, and so on. For binary, however, it's the same thing, just that fewer digits and the exponentials are smaller. So instead of 10 digits, we have only 2 digits, 0 and 1. And instead of the exponential powers being in the ones place, tens place, hundreds place, and so on, the ones place, twos place, fours place, eights place, 16th place, and so on. For example, number 63 will be represented with 111111 in binary. So, which is equivalent to 1 plus 2 plus 4 plus 8 plus 16 plus 32, which is equal to 63. And now that you know what binary basically is, we're going to move to the solution. So like before, you enable each bottle with a number, but in base 10. However, below that number, you are also going to write its base 2 counterpart, which you can calculate. I've done some of this before. So let's see, we are trying to find out 53 and its binary expansion. So we subtract the biggest factor that fits in it, then subtract the next biggest power from the difference, and we continue this till we get down to 1 and that or 0, and that will be the decimal expansion. Then we are going to feed the wine to the rat like this. Set up the rats, which I'm going to represent with small circles, in a line of 10. These rats are going to represent places of the base 2 expansion. And then you take the number of the wine and then feed it. And then every 1 in the number, you feed it to the rats. For example, let's say we are feeding the 63rd bottle and its decimal expansion is 111111. So we're going to feed it to this rat, this rat, this rat, this rat, and this rat, and this rat. Another example, let's say we have the 128, which expands to 1000000. Now we are going to feed only this rat here. And we are going to continue this for every bottle. Once we have given each rat the proper wine, we wait an hour. And then we are going to have a line of rats, some dead and some will be alive. So I'm representing the alive rats as the clear circles and the dead rats as the filled circles. So then you just imagine that all the dead rats are ones in the decimal expansion, while all the alive rats are zeros. So let's see that the setup of dead and alive rats looks like this, with this rat, this rat, this rat, and this rat being dead. So we take 1, 8, 16, and 64. We add those numbers, and the sum we get is the number on one of the bottles, and that way we can take away that bottle and save the other 999 bottles of wine. For example, in this case, we are going to have 1 plus 8 plus 16 plus 64, which is 89, which means that bottle 89 is poisoned, and thus we throw away bottle 89. That's the solution.